Okay, so here we are in the grade 3 introduction of the Common Core website. Hopefully that looks like it is visible and legible. So, as is my custom here on this channel, by the way, if you're just joining us, hi, my name is Professor Cunningham. I take all of these videos and I chop them up into bite-sized chunks and I put them up on my YouTube channel, which you can find at professor-cunningham.com. And I very much hope you'll join me. I do this every Monday at 6 p.m. Pacific. All right, so grade 3 introduction, we're going to talk about a general overview of what is expected and what students should expect to know, and more importantly, what parents and teachers and mentors should expect their students to be able to do and understand and communicate by the end of 3rd grade. Now, again, I want to really stress that every student learns at their own pace. So this is going to be wibbly wobbly. And I am really interested in pushing for a multi-year approach to math rather than trying to shove all of a particular kind of math into 1 year. I think that students should be allowed to learn at their own pace throughout their whole math careers. But again, neither here nor there. This is a general idea of what you should be expecting. If a student isn't quite at this level, that's okay. Continue to practice the fundamentals that we did in last videos, and you know, it's easier for some folks than it is for others. And you never know. Students that struggle really hard right at the beginning are often students that end up going to the highest levels later on because they know how to struggle and do so productively rather than just assuming they can coast to the correct answer. So anyway, rant over. Again, in grade 3, instructional time should focus on 4 critical areas. 1, developing understanding of multiplication and division and strategies for multiplication and division within 100. So again, we are now going back to multiplication, but now we are explicitly going into multiplication. We are talking about it as multiplication and division now. Up until this point, we've been doing array or counting by 5s and all that other stuff, which is leading to multiplication, as well as cutting rectangles up into chunks. But what we haven't done yet is actually called it multiplication. This is when that happens. Developing understanding of fractions. One moment. There we go. Developing understanding of fractions, especially unit fractions, which are fractions with a numerator of 1. 1/2, 1/3, 1/10, whatever. That's a unit fraction, unit meaning 1, right? The word unit meaning 1. Students develop, developing understanding of the structure of rectangular arrays and of area. So we're going to start talking about area. And describing and analyzing 2-dimensional shapes. Again, same general idea that we've been doing in kindergarten and 1st grade and 2nd grade. We're just taking it to its next logical step. We've already counted by 10s. We've already done array addition, where it's like 5 + 5 + 5 + 5. We know what area means, sort of. We know what a larger or smaller circle means. So now it's time to put words to all those ideas and give us the vocabulary so that we can communicate about math more effectively. So, number 1, students develop an understanding of the meanings of multiplication and division of whole numbers through activities and problems involving equal size groups, arrays, and area models. Multiplication is finding an unknown product. That is a piece of vocabulary that is very important. Product is the answer to a multiplication problem. And division is finding an unknown factor. And it's really important that we get this word factor understood as much as possible. When you have 2 numbers that you're multiplying together, the answer is the product. But the 2 numbers you're multiplying together are called factors, or 3 numbers, or however many numbers. And that word factor will continue to be used over and over and over again. So later on in high school, where I actually teach, when you start learning about factoring, It means taking a number or an expression and breaking it up into things that multiply together to make that, like 10 is 5 times 2. For equal size group situations, division can require finding the unknown number of groups or the unknown group size. So if I have, well, I'm not going to give an example because they might, but we will be asked to both be told, or to both tell, if we take a number of things and divide it into a certain number of groups, how many groups if each one is a certain size, and how big does each one have to be if we want a certain number of groups. So it's the same question, but we're looking at division from a few different ways. Students use properties of operations to calculate products of whole numbers, using increasingly sophisticated strategies based on these properties to solve multiplication and division problems involving single-digit factors. Single-digit factors means 2 times 4, etc. The times tables are kind of outdated. We don't really memorize the times tables anymore, but it is still a useful tool for students who do like to or are good at memorizing. Some students are just able to memorize the times tables, and that's okay. That is fine, so long as they are able to also explain the multiplication in some alternate way if someone doesn't understand how they did it. I did it in my head is a true statement, but it's insufficient in mathematics. You need to be able to explain in some way, somehow, what your thought process is, which is why this vocabulary is so important. By comparing a variety of solution strategies, students learn the relationship between multiplication and division, just like we did with addition and subtraction. In fact, the relationship between multiplication and division mirrors the relationship between addition and subtraction so closely that a lot of these problems are going to look very, very, very familiar. And a lot of the litanies and chants, 8 plus 5 is 13 because 13 minus 5 is 8. We're going to be doing a lot more of that. It's just going to involve multiplication and division. So we'll be on familiar ground. We will be on familiar ground. Number 2, students develop an understanding of fractions, beginning with, there's this phrase again, unit fractions. Students view fractions in general as being built out of unit fractions. So if I have 3/7, that is 1/7 and 1/7 and 1/7 together, right? And we're going to be using a lot of cutting up shapes to visualize this. Students view fractions in general as being built out of unit fractions, and they use fractions along with visual fraction models to represent parts of a whole. Students understand that the size of a fractional part is relative to the size of the whole. For example, let's see if we can make this example understandable, shall we? 1/2 of the paint in a small bucket could be less than 1/3 of a much larger bucket, and that makes sense. Like, that makes perfect sense. I would say like a gallon of milk versus a half gallon of milk, but that would just be my way of putting it. But 1/3 of a ribbon is always longer than 1/5 of the same ribbon, because if you cut it into more equal pieces, each piece is going to be smaller. We talked about that in 2nd grade. We talked about it quite a bit, and now we are building on that idea to create a more sophisticated understanding of fractions. We're doing it early, and we're doing it in a way that is gradual and gentle enough that it will hopefully be able to ease some of the fraction phobia that a lot of students have all the way up until their adulthood. Okay, students are able to use fractions to represent numbers equal to, less than, and greater than 1. So the basic idea there is you want to make sure you know that if a bigger number is on top, then it's greater than 1. If a bigger number is on the bottom, then it's less than 1. And if the two numbers on the top and bottom are equal, then it's equal to 1, right? 5 divided by 5 is 1. 5 divided by something larger than 5, like 10, is less than 1. It's 1/2. So that's the idea. They solve problems involving fractions, involving comparing fractions, by using visual fraction models and strategies based on noticing equal numerators or denominators. We are going to talk about these words, numerator and denominator. However, I do have a video on my YouTube channel at ProfessorCunningham.com. I'm sorry, Professor-Cunningham.com. I couldn't get ProfessorCunningham.com. It was already taken. Professor-Cunningham.com. I have a video, which I should hopefully be linking right now when we do this on YouTube, that talks about why the numerator is called the numerator, why the denominator is called the denominator, and it's actually a really fascinating look into how math and language intersect and why mathematicians use the sometimes arcane-seeming words that we use. And most of the time, not all the time, most of the time, the words we use actually make sense. Numerator and denominator make perfect sense once you know what they mean. Moving on. Number 3, students recognize area as an attribute of two-dimensional regions. So like my screen right now has area. So we're expanding from one dimension where it's just along a line, and there's only length, right? There's only going up or going down. Now we have area. And then, of course, later on in 5th or 6th grade, whenever, we'll start generalizing to volume. So let's see. They measure the area of a shape by finding the total number of same-size units of an area required to cover the shape without gaps or overlaps. A square with sides of unit length, remember unit means 1, so it's sides of length 1, being the standard unit for measuring area. So we're going to measure area by taking little squares and like covering images to see how many squares it takes to make the image. I should really be gesturing with my left hand because my right hand goes off the camera all the time. So in an actual physical classroom, we would probably have actual physical little unit squares, and we would cover up, shapes to try to count out the area at first. Later on, we'll get shortcuts like length times width. And for those students who are really clever, they'll notice that we've already been doing length times width in 1st and 2nd grade. Speaking of which, students understand that rectangular arrays can be decomposed into identical rows or into identical columns. We did a bit of that in 2nd grade. By decomposing rectangles into rectangular arrays of squares, students connect the area and multiplication and justify using multiplication to determine the area of a rectangle. A lot of students are taught, and a lot of teachers still teach, that arithmetic / algebra and geometry are two totally separate beasts, and they're just not. They're just not. Multiplication is the same thing as area. It's the same thing as like scaling up and scaling down. It's so inextricably linked. You get area of the most basic shapes by using multiplication. So it's really important that students see right now the link between shapes and numbers, and thus numbers and the real world, because the real world is made up of shapes. More complicated shapes, sure, but we're still only in 3rd grade here. Number 4, students describe, analyze, and compare properties of two-dimensional shapes. They compare and classify shapes by their sides and angles and connect these with definitions of shapes. Students also relate their fraction work to geometry by expressing the area of part of a shape as a unit fraction of the whole. So that's, again, just a visual aid. We are going to be looking at multiplication, division, and fractions in a bunch of different ways. And we're not going to rely on only one trick or one formula or one mnemonic device. We're going to give a lot of options, and students will want to try to understand the patterns behind the problems. Okay, so now let's move on to the grade 3 overview. This one's very quick. So we are going to be breaking up our learning into the following subcategories. Operations and algebraic thinking, which is divided into represent and solve problems involving multiplication and division. Yeah. Understand properties of multiplication and the relationship between multiplication and division. Multiply and divide within 100. Solve problems involving the 4 operations. And identify and explain patterns in arithmetic. Now, when they say operations, the 4 operations, they mean addition, subtraction, multiplication, and division. and how they're all related to each other and how they all work together to help you solve problems. The second bit is number and operations in base 10. Use place value understanding and properties of operations to perform multi-digit arithmetic. That's basically everything that we did in first and second grade, kind of compressed, right? So we're going to be doing a lot of reviewing of how to break numbers up into their place values and multiply and add and subtract and divide them in that way. Let's see. Numbers and operations, fractions. We're going to develop understanding of fractions as numbers. What does 1/2 actually mean? Where is it on the number line? What does it mean? What are the other ways that we could write it, etc., etc.? We're going to try to, and this is a big, big, big goal of my stream right now specifically, is I really want adults to be watching this, and hopefully by watching a grown-ass adult doing third grade math, hopefully I can take some of the fear away from those adults who are still afraid of fractions. That is my biggest goal in doing this right now. So I really am planning on promoting my videos on fractions very heavily, and I hope that you'll stick around with me for it. Because fractions are the first really, really big hurdle that students hit, and some students never get past it, and that is very sad to me. Not like pathetic sad, like actually sad sad. So I'm going to do everything I can to try to help. That's what I'm here for. So measurement and data. Solve problems involving measurement and estimation of intervals of time, liquid volumes, and masses of objects. And by the way, another mini rant, I know that a lot of that fear of fractions comes from the fact that you weren't taught fractions in the kind of way that we're going to be learning it here, and also because a lot of you had really crappy teachers, and I'm sorry for that. It definitely happens. Yeah. And again, everyone learns at their own pace. I've already said all this stuff. Moving on. So we're going to solve problems involving measurement and estimation of intervals of time, liquid volumes, and masses of objects. I'm not sure exactly what that means, but I imagine it's something like if I have a leaky bucket, then you know, if it starts out with a certain liters of water and it ends with certain liters of water, how many did it lose? Or something like that. Maybe. I don't know. Represent and interpret data. That's what we've been doing. We're just going to have more and more ways of showing data which will be useful in different situations. Geometric measurement. Understand concepts of area and relate area to multiplication and to addition, right? If you have two different areas and you're trying to combine them together, you add them. But to find the initial area of a rectangle specifically, you're going to multiply. And all area is going to involve multiplication in some way or another. Every single area formula involves multiplication in some capacity. It literally has to. Geometric measurement. Recognize perimeter as an attribute of plane figures and distinguish between linear and area measures. That's really important. A linear measure is how far apart or how far apart my two walls are in my apartment. The area is how much floor space there is, right? 1 dimension, 2 dimensions. And even when it is a perimeter around something, it's still a one-dimensional shape, right? If I took that perimeter and drew it out, I could like stretch it all out into one line. Whereas you can't do that with an area because it's a two-dimensional thing. Okay, measurement, okay, geometry, reason with shapes and their attributes, that's just a catch-all. We're just going to do some more vocabulary. Shapes are really all about vocabulary. We're going to learn about probably acute and obtuse angles, and we'll probably, I don't know exactly. We'll find out. And of course, zooming in a tiny bit more because these are the most important piece. Again, these are at the bottom of every single grade going all the way up. These are the 8 mathematical practices that underscore and drive everything that Common Core does. So like always, I'm going to read them out, and I'm going to give hopefully a very, very short idea of what each of them is going to mean in 3rd grade specifically. Number 1, make sense of problems, persevere in solving them. That's a life skill. It's going to be around no matter what. And it's the core of everything we do, right, is solving problems. A lot of people think math is about creating problems. It's not. It's about solving them. Number 2, reason abstractly and quantitatively. Abstractly just means using descriptive words. Quantitatively means using numbers. Number 3, construct viable arguments and critique the reasoning of others. Again, that just means understanding the various ideas when it comes to, in this case, mostly multiplication and division. You should be able to explain your work to somebody who doesn't understand, and that's a part of learning how to quote unquote do math. Math is about communication. Number 4, model with mathematics. This is the when are we going to have to use this in real life? Modeling with mathematics means using math appropriately in real life or real life adjacent situations, sometimes involving an unnecessary amount of cantaloupes. Number 5, use appropriate tools strategically. We've got a bunch of tools in our toolbox now, and we have ways of breaking apart numbers, and we're going to be able to upgrade those tools essentially to be useful outside of what we already know. So we want to make sure that we're using the right idea for the right job. There are always many, many ways to solve a problem, and they are all valid, but we always want to be thinking about what is the most efficient route. What is the one that saves me the most work? And that's a thing that a lot of math students are interested in. That's the thing a lot of mathematicians are interested in. Get the problem done using appropriate tools so that you don't have to do as much work. Attend to precision. Again, attend to precision does not always mean take it out to 19 decimal points. Precision just means precision in your language, precision in your vocabulary at this point. When you are talking about math specifically, try to be as precise as you can in your language. Try to speak using mathematical vocabulary as much as possible and get comfortable using it, both as a parent, as a teacher, and as a child. And helping your young student talk this way is going to involve sort of engaging them in ways that might be tough. So math can be frustrating. I know. That's why I'm here. We're going to check 1, 2. We're going to look for and make use of structure. And again, that just means we know how numbers are put together. We know how they're constructed. We know how to take them apart and use that to our advantage. And then look for and express regularity in repeated reasoning. A lot of the rules of addition and subtraction are going to have very analogous rules in multiplication and division. And the faster students make that connection, the much easier this leap will be, and the much easier both fractions and later negative numbers will be.